Hello everyone and welcome to this week's very exciting After Effects scripting tutorial. In this one, I'm going to be showing you how to make this Kaleidoscope script that replicates this actual kaleidoscope I got. This tutorial is going to be fully in depth from when we first look through our kaleidoscope. We're going to analyze what we see, write it down, work out the math, and then write the code to make it work. And this is going to be our final result here, which is mostly similar to the actual kaleidoscope here. We're going to look at actual images through it, which I used for reference, essentially looking at grids and orientations of arrows, and it's going to recreate this look, which will take our original video and slice it up and have the nice background there as well, which we can remove to keep this effect or have this nice background kaleidoscopic effect. And with our script, we're going to have one input for the resolution, which will decide sort of how many or how big each of the pieces are going to be. And before we get started, just want to remind you down below, hit subscribe, hit the bell icon to be notified of new videos coming out twice weekly. And down in the description, of course, you can check out and download the code for this Kaleidoscope script, as well as you can follow us on Instagram to be notified of when videos go live. And of course, join the Discord to get help with scripting, extensions, plugins, expressions, and much more, and help others out in the community. So back before the world shut down in January, I went to France and I got this Kaleidoscope at the Louvre, which just has some French patriotism on it, as well as a nice effect. Now, what you're looking at right now is an actual image I took of it, not very high resolution because the peephole is very small, but essentially this is what the image looks like. You can tell there's a lot of triangles and hexagons and a lot going on. So the first step in tackling recreating this effect is to really just spend time looking through it, looking at certain objects, and then we need to map out by hand how this is working. So this here is the original thing I used to figure out how it worked. The image you saw was a picture of this through the kaleidoscope. Essentially, it has a top, right, bottom, and left arrow marked off so that I can know which way each of the triangles needs to be rotated inside of the kaleidoscope. I also marked them with colors to make it a lot easier to see them in a small resolution. So then I could track which way each triangle was rotated, as well as which way it was scaled, whether it was flipped or mirrored, and every property necessary. Then I moved on to actually writing it down, and I recreated a smaller structure of the overall thing. And I started by looking at a center hexagon to figure out which way each thing was rotated, as well as how the scale would be manipulated in After Effects. So knowing that I was going to be using masks to cut out each image into a triangle, I decided to make the base triangle shape like this, where the top was on this side and the orientation was like this. So I started off with this as my central triangle with a rotation of 0, but it was also mirrored on this axis, so the scale would be -100 and 100. Then I continued to go around and figured out that everything rotates around this center point. So we get 1, 2, 3, 4, 5, 6 triangles per center. So ideally our program can go from center to center, generate 6 triangles, and then move on to the next center and keep generating them. And remember, we're just using the original image, so it's all going to be a replica with a rotation change and a scale flip change. Hopefully that makes sense, but essentially what happens is you get 6 different configurations for the triangles. You get one that's pointed up, down, etc. And each one has a rotation between 0 and 300, which basically is 360. And then the scales will each go back and forth between normal and flipped vertically. So essentially what I realized is that we can take this and treat it like a square. We can have a for loop on the x-axis and a for loop on the y-axis to go through and create all of these triangles. So what we're going to basically do is go from left to right, like we're looping through them like this. So we're going to have basically 2 nested loops, one starting here and then going across to each of these. And for each time we create a new triangle, we're going to add to our tri-state int. This is not the tri-state city or tri-state area. This is the triangle state. So if it's triangle state 0, it's the very first version, which is starting on the left here, 300 degrees rotated, as well as a normal scale. And then the next triangle we add is going to be the next one, which is our triangle number 1, which has a rotation of 0 as well as a backwards scale. So if you're still having trouble understanding how exactly this is working or how we're going to be programming it, just know that I took a picture of this through the kaleidoscope And after that, I figured out if I make a triangle for each one, which is going to create a triangle in the center of the image, which way does it need to be rotated in order to fit this reference image? Essentially, all we're going to do is take this information we extracted of which way it needs to be rotated and which way the scale needs to be changed, and iterate through here in our 6 different cases, and each time just keep going to the next one. So as you can see through my phone here, things are all just triangles rotated in different ways, and some of them are flipped on the vertical axis, which I inferred through my observations. Alright, so that's sort of all the behind the scenes methodology and figuring out that I did to figure out how we're going to recreate this effect. You'll notice, of course, that there are 2 triangles missing between every shape, which I think in my case is fine. I kind of like how the look turned out, but if you wanted, you could go in and work on this yourself and adjust it so that these last areas get filled in as well to make a full kaleidoscopic effect. But we're going to go ahead and create a new JavaScript file and just dive straight in here. We're going to start off by making this super simple UI, which has a group for our resolution input and a group for our generate button. So we're going to start by creating a variable called window and set that equal to a new window, and the type is going to be a palette window. We'll call it Kaleida, and it will have an undefined size. Then I'll take my window and set the orientation to column so the groups within it go from top to bottom, and I'll create 2 groups, one called group 1, which we'll add to the main window as a group, undefined size, and we'll just have it say group 1, but this text won't be displayed. Then we want everything in group 1, our text and our input, to go from left to right, so we'll make it a row. So I'll say group1.orientation is equal to a row, and I'll create our second group as well here. I'll just copy and paste this code and change group 1 to group 2 and group 1 to group 2. Now I can go ahead and add my resolution text. I'm not going to actually create a variable, I'm just going to insert it into the UI. So I'll say group1.add static text. It's going to be undefined in size, but it's going to say resolution. Then I'll create a variable called my resolution edit text, or redit text, and I'll set this equal to my group 1. Instead of adding a static text, we're going to add an edit text, and the text inside will say 250 as the default. Then lastly, we need our generate button, and we'll add this to group 2. We're adding a button, undefined size, and we'll just call it generate. Then lastly, we can grab our window and center it in the middle of the screen, and we'll also show it. So now we have the same exact UI. Actually, we need to make the redit text a little bit bigger. So I'll say redit text, and the number of characters I want to be able to fit is 5. So now we have our UI complete and everything looks the same. We now need to generate our code and basically the process to create all of this given our resolution and selected layers. Oh yeah, and we shouldn't forget we have our tri-state counter integer, and this is going to be equal to 0 because we need to keep track of which triangle we're looking at or generating, and this is going to be global. So now we can grab our generate button, and we initiate everything when we click on it, so we'll create an onClick function, and we need to first check 2 things. We need to make sure they have a composition selected and at least a layer selected. So I'll say if and another if. In the first if, it will be our comp check. So if app.project.activeItem is equal to null, or if it's not a comp item. So if app.project.activeItem, but we're inverting the logic by adding this exclamation mark. And if this is the case, we'll say, please select a comp and return false to exit out of this bit of code. Then we need to check if there are selected layers. So I'll say if app.project.activeItem.selectedLayers, and if the length of that is less than 1, we know we don't have any selected layers. So we'll say, please select at least 1 layer and return false again. Now, if the user makes it past all of this code, we know that they have selected layers and a comp, which is perfect. So now I'm going to go ahead and create a few variables that I used in the previous example. We want our blur effect, which we're going to be applying to the background at the very end, just to blend it in a little bit. We're going to have an array full of triangles for all the triangles we generate. And we're also going to have something for this layer as we loop through the layers. And our pre-comp, which is what we're going to do, is we're going to pre-compose all of the triangles we generate. And then our layer counter, which keeps track of what layer we're on. And the reason we're using a layer counter is because we're also going to have an array called indices, because in order to pre-compose some layers, you need an array of each of the indexes or indices of those layers. So we're going to use our layer counter as we're looping through and store all of the indices in here so we can pre-compose them at the end and have a nice organized look. Then based on my mathematical algorithms, I need a variable for the width, and this is going to be our resolution input. So I'm going to say var w is equal to parse int, and we're going to grab our resolution edit text and the text inside of it. We're going to convert this text into an integer. Then now that we have our sort of width defined, each of these is going to be about 250 pixels because we're going to divide it by the resolution. So we're going to create our iterations now. I'm going to say iterations, the number of times we're going to go from left to right, up to down essentially, is going to be equal to our app.activeItem.width divided by our w variable. So that's going to, in this case, take 1920 divided by 250, which means it's going to go across here approximately 7 times before it goes on to the next row. We're going to be essentially doing a for loop 7 times across, 7 times up and down. Of course, you can put in your own inputs if you want to have a custom width or height input. But for mine, I thought having just one element to control everything would be pretty cool. And then lastly, we need to sort of have our origin or starting position, because as we loop through, we're just going to add the width and the height for the position. So for our original position, we don't want it at the very origin at the top left. We want it a little bit down, but not going left or right at all. So we want it essentially lined up right here in the corner-ish, which mathematically speaking we can define. We'll say var position is equal to something, and our position w or x, it's going to be right on the origin line, so we'll set that to 0, and the y, we want it to start a little bit down here. So what we're going to do to do that is grab our comp height by saying app.project.activeItem.height divided by our width again here, and we're going to multiply that by 0.5. So what that should do is basically take the length of one of these elements and divide it by 2, and then half of the element will sit like this. So half of the element here is on the other side, so it bleeds out like this. I thought this style looked best, and it seems to work out the best in this case. Now lastly, we're going to go ahead and loop through and create our elements. So I'm going to say app.begin undo group. We need to be able to undo all of this pretty easily because it's a lot of stuff. And our app.end undo group, and we'll call this triangle generation or something. And then the first thing we're going to do is loop through all of our selected layers. This supports many different layers instead of just one. So we're going to say var I is equal to 0 for I is less than our app.project.activeItem.selectedlayers.length, which we already checked that we have some. And then we're going to say this layer, which we defined earlier, is equal to our app.project.activeItem.selectedlayers.I. This will just make it a lot easier now that we don't have to keep typing this over and over again. Now we're going to use our nested for loops to basically loop through the y and the x axes. So I'm going to say for inside of a for loop. We're going to say var y is equal to 1, and for y is less than or equal to our iterations, increment y by 1. And for var x is equal to 1, do the same thing, x is less than or equal to our iterations, increment x by 1. Then there's a few things we need to do each time through. We're going to say triangles, which is our array we set up here, dot push, and we're going to create a function called generate triangle, which we'll define in a minute. Then I'm going to grab my indices array and push in our layer counter, which remember we're keeping track of all those to pre-compose them later. Then I'm also going to create a function called setPosition, where I give it this layer as well as my position, and it will automatically set that for me. And then I need to then iterate my counters. So I have my layer counter. We've created a new layer, so it needs to be incremented. And then also for our tri-state counter, our triangle state has now changed. We created a triangle, the next state needs to be realized. And don't forget, our tri-state counter only goes up to 5. So we need to clamp it if it goes above that. So we'll say if tri-state counter is greater than 5, then tri-state counter needs to go back to the beginning, and we'll set it to 0. Another thing we want to do if the tri-state counter resets and goes back to 0 is we want to move on to the next shape. We only go 6 iterations through each of these, so once tri-state counter has been reset, that means we need to move on to the next shape. That means we need to increase the position over by the width amount, or in our case, the width times 2. So I'm going to say position is equal to itself plus the width times 2, and then 0. So now if you're thinking ahead, you might be wondering, all right, so we're going across as we create the shapes, but when do we go down to the next row? Well, the case we go down for the next row is also contained inside of here. If we're restarting to the next shape, basically is what this is saying, if we finished one of these little kaleidoscope shapes, we've reset our triangle state. So after that, we basically need to say, if our position is currently past the composition width plus a little bit extra, we want to go down to the next row. So I'm going to check if our current X position, basically remember the positions are the centers here that these triangles rotate around. We're going to say if that is greater than, if it's greater than our comp width. So if active item.width plus our W variable. The reason we're adding the W is because it provides this padding here. Because technically this X position here is greater than the width of our composition. We need to make sure it's greater than a little bit more. That way, in case if we want this bleeding here, we can have elements on the edge. Otherwise, it would just be empty and look a little bit weird. So if that's the case, we're going to actually just set position. We're not going to add to it. We're going to set the X to 0, start back at the left side at the beginning, and then we're going to multiply our width times 0.5, so half the width basically of our entire shape here, and then multiply that by y. And the reason we multiply it by y is because at this point y is going to be 2, and then we can move on to the next row. So before we can actually test any of this, we still need to define our two functions. One of them is called generate triangle, and the other one is called set position, which really you could do with one line of code, but in this case I'm just illustrating it if we wanted to do some more custom things inside of this function. So for our set position, again, we need our layer and our position value sort of, and I'm just going to grab layer.property, Adobe transform group, and then I'll grab the property called Adobe position and set the value to our position value. Again, you could put this one line of code up here, but if you wanted to do extra things like apply expressions or do other things, you could do that inside of this function and have more control if it goes wrong. Okay, and then for our generate triangles, we need a few things. The first thing is going to be our tri-state counter. In the original example, I did this, even though it's a global variable, just so we can know that it's there and remember what we're using it for. We're also going to want our layer, so I'll say this layer, and we're also going to want our iterations amount. And then down here, we'll define these arguments as our counter, original layer, and iterations. And actually, we can probably just refer to this as the width, and this is the index. And now what we're going to be doing is creating our triangle itself by basically cutting a triangle out in the middle using a mask and our width. So what I'm going to be doing is creating a bit of code that creates our, remember, original triangle shape. And then it needs to also then move the anchor point down to this corner here. That way we can rotate it as we needed as we analyzed this process. So I'll create a variable called comp. We already know we have an active comp open, but now let's just make a variable to track it easier. And then I'm going to say comp origin. We're going to be basically creating everything around the origin area. So we need to get comp.width times 0.5 and comp.height times 0.5. That way that's the very center of the comp, which is basically where our anchor point is going to be, and then we're going to move our anchor point plus the width. Create a variable called triangle width to make sure we have a variable to know how wide our triangle is. That's going to be our comp.width divided by width. Now I'm going to create a variable called triangle layer and set this equal to our original layer, and we're going to duplicate it. Now we've duplicated our original layer, we can start applying masks and things to it. So I'll create a variable called triangle shape, and this is going to be equal to a new shape object, and a shape object contains vertices, intangents, outtangents, and basically are equivalent to a mask shape or a shape layer shape. And what we're going to do is say triangle shape.vertices is equal to this. This is the algorithm to generate a triangle based on our width. And basically this algorithm here will generate our triangle based on our comp origin and our triangle width. It will look at the comp origin and move the points away from it in the proper widths. Then I need to create a new mask, so I'll create a variable called mask and set this equal to our triangle shape.masks. I'm going to add a property called mask. And then I'm going to take my mask and the property inside of it called mask shape, and I'm going to set the value to be our new triangle shape. So essentially we're creating a new shape that is a triangle, and then we're adding a mask, a brand new mask on our layer, and setting it equal to that triangle shape. Then we can go ahead and set the anchor point of this layer to be in that right corner. So I'm going to say triangle layer dot property. Oh yeah, and I also need to change this to triangle layer, not triangle shape, and make sure it's all set up right here. So I'm going to say triangle layer dot property Adobe transform group dot property Adobe anchor point, and we're going to set the value. And what we're going to do is set this equal to itself dot value, and we're going to add 0 to the W or the X, and for the Y we're going to move it down the triangle width divided by 2 or times 0.5. So what this is saying is it's going to set the anchor point to be itself, which is currently in the origin of the composition, plus 0 on the x-axis, but we're going to add half the triangle width, which will set it right there and allow us to rotate it around this center point. We still have a few more things to do, but we can return our triangle layer and actually see if any of this is running for us. So I'll go ahead and run this and select 250, make sure I have a layer selected, and hit generate. And I forgot to reference our app.project.activeItem. And now it looks like we're generating a bunch of triangles, which is good. The positioning is not looking as great. It looks like the anchor point is off on all of these, so let's go ahead and fix that. Alright, next up we need to check which state we're in, which tri-state int we are basically reading, and then rotate or scale the layer appropriately. So I'll create a variable called rotation and one called scale. That's an array. And then we're going to use a switch statement for our index, and we have our 6 cases for each of the types of triangles. And basically we're going to set these up so that they're exact same as we wrote down as we were looking at how things were rotated. So for each of the cases I put in the right rotations and scales they should be at, so whenever we get to that triangle we now need to set these values. So I'm going to say triangle layer, and I'm going to grab this information here. Instead of anchor point, we're going to set the rotation, which is Adobe Rotate Z, and we're going to set the value equal to our rotation. Then I'll duplicate this, and instead of rotate Z, we'll say scale, and we'll set this equal to our scale. So now let's go ahead and run it and see how we're looking. Now you can see we're getting more defined shapes appearing. So if you're having strange issues, I just realized an issue that was happening. So the anchor point of this layer was originally down here, and whenever I hit generate, it kind of scattered everything around. But look what happens when I reset my transform and run it. Then I get the actual proper shape because everything's already working technically. So if you're having issues where it's not appearing at this point in your code, be sure to check that your anchor point is reset, or manually go in here and reset the anchor point of your OG layer. The last things we're going to do is pre-compose everything. So I'm going to say pre-comp is equal to app.project.activeItem.layers.precompose. And we're going to pre-compose with our indices as well as call it pre-comp. And then lastly, if you want, you can add code to add a Gaussian blur, whatever kind you want, to add a blur to the background to make it stand out a little bit more. So if we go ahead and run our script now, we'll go ahead and select something different like 100. And now when we hit generate, we're going to get much smaller kaleidoscopic effects, but we should be in pretty good shape here. One thing I think I forgot to mention is that I had to increase the for loop in my Y direction. You can see here, instead of 4y is less than our iterations, I multiplied it by 2, which you can see is creating a little bit more kaleidoscope than we wanted, but I was having issues where it didn't generate enough of these shapes. So I just multiplied the iterations by 2, and now it looks like we are getting our appropriate kaleidoscopic effect. But that's going to do it for this week's After Effects scripting video, guys. I hope you enjoyed this in-depth tutorial on recreating a real kaleidoscope inside of an After Effects script from beginning to end. If you enjoyed the video, hit the thumbs up button, hit subscribe down below, and hit the bell icon to be notified of new videos coming out twice weekly on the channel. And down in the description, you can download the code for this in the GitHub link. And also down there, follow us on Instagram to be notified of when new videos are coming out. And of course, make sure you follow us on Discord, where you can join in and help others with scripting, extensions, plugins, and expressions. The community is currently thriving quite a bit. There's lots of discussion going on, and it's growing rapidly. But that's going to do it for this week's video, guys. I hope you enjoyed. We'll see you next time.